So to figure out the domain of a function, we generally can plug in any number we want for x. And usually the domain is all real numbers. And to indicate that, we go from negative infinity to positive infinity. For example, if I give you the equation f of x equals 2x plus 3, and I wanted to make a chart for this, x's versus y's, I could plug in any number I want for x, and I'll always get out a value for y. So the domain will be all real numbers. There are two exceptions that we talked about in class, and if you have these exceptions, you have to note them in the domain. One, if you have a fraction that you're starting out with, the denominator cannot be 0, which means you set the denominator not equal to 0, solve for x. That's your restriction. Two, the second exception, under an even root radical, you can never have a negative number. So underneath the radical has to be greater than or equal to 0. And it can be any even root. So a square root, a fourth root, any even root. Doesn't matter. We're only worried about the stuff under the radical. It's also called the radicand, can never be a negative number. So let's take a look at a few of these examples here. We'll start with the radicals. F of x equals the square root of, again there's a 2 there that is understood, x minus 2. Because it's an even root radical, I've got an exception. Under an even root radical, it can never be negative. So I set x minus 2 greater than or equal to 0, solve for x. And because there's an equals on here, you can take a look at it on the number line. That means it's a filled in dot on 2 and it goes off to the positive infinity direction. But instead of using open dots and filled in dots, when I see a filled in dot, I'm going to think bracket out to infinity. And the reason for that is when I write this in interval notation, I end up with something like this. Starting from left to right, I start at 2, I go to infinity, it's a bracket on 2, a parenthesis on infinity. Because I go from left to right, the number that I write down first should be smaller than the second number that I write down. In interval notation, the number on the left is the small one, the number on the right is the bigger one, in this case infinity. Next to infinity symbols, you always put parentheses. All right, so if I have a function like this, g of x equals the cube root of x minus 2. Normally the answer is all real numbers unless I have one of these two exceptions. One, I don't have a denominator in this problem except for 1, and that's never going to be 0. So I don't have to worry about exception number 1. Exception number 2, under an even root radical, well, I don't have an even root, I have an odd root. Since I don't have either of those two exceptions, the domain is simply going to be all real numbers, which means I can plug any number I want in for x and it'll come out a real number. So for example, if I plug in a -6 for x, just randomly pick -6, I'm going to get the cube root of -6 minus 2 is -8. But the cube root of -8 does come out a real number, -2. I can have a negative under an odd root. I just can't under an even root. And it doesn't matter, again, what even root you're talking about. So if I have h of x equals the fourth root of x minus 2. Okay, once again, it's under a radical, and it's an even root, which means I set the radicand, oops, let's make that a 2, not a 4. I set the radicand, which is the thing under the radical. I don't worry about the radical symbol. I only worry about the radicand greater than or equal to 0, solve for x. So it's going to come out the same exact answer as what my f of x domain was, from 2 to infinity, including the number 2, because there's an equals on there. You can have the under the radical equal to 0, because you can take the fourth root of 0 or the square root of 0. You just can't take the fourth root or the square root of a negative number. Right? So moving on to our fractions, if I have p of x equals x plus 5 over x minus 2, the denominator cannot be 0. The numerator has nothing to do with this. The numerator could be any number we want, as long as it's not under a radical symbol. I don't have a restriction up here, but I do have a restriction in the denominator. So if I take a look at that restriction, x minus 2 can't be 0. You can't divide by 0, so that whole thing can't be 0. Solve for x. So the restriction is x can't be 2, which means on a number line, it can be anything else, just can't be the number 2. So I'm going to put an open dot on 2, and that means I can shade either side of that. So going from left to right, I start at negative infinity to 2, and then pick it back up on the other side of 2 to infinity. Notice how you have two regions that you shaded in. You should have two intervals then in your domain. So that's your domain for that problem. If your domain is a little bit, or if your rational function is a little bit bigger, so let's say it's g of x equals x plus 5 over x squared minus 2x minus 3. I still have no radical here, so I don't have to worry about the, greater than or equal to 0 or anything like that. But I do have a denominator, and I know that denominator cannot be 0. So I solve this quadratic equation by either factoring it, or you could use the quadratic formula, but most of these you'll be able to factor. So I have x minus 3 times x plus 1. Can't be 0. Has to multiply to negative 3, but add to negative 2. Set each of the factors not equal to 0. And then solve for x. So now you've got two places that you can't use, or two numbers that you can't use in that denominator. So think about it on a number line, what that looks like. You can't use negative 1. You can't use 3, but you can use all the other numbers on the number line. So I have 3 filled in spaces, so I'm going to have 3 intervals from negative infinity to negative 1, parenthesis, because it can't equal, open dot, between negative 1 and 3, and then 3 out to infinity. Parentheses on everybody. So where it gets a little trickier is when you have a radical in the problem and it's a fractional or a rational exponent. So h of x equals the square root of x plus 5 over x squared minus 2x minus 3. So I look at the numerator, it's an even root. If it's an odd root, I don't even mess with it. But if it's an even root, I've got to report the restriction. So the restriction is this. X plus 5 has to be greater than or equal to 0. The restriction then is x has to be a number bigger than or equal to negative 5. The denominator can't be 0. Right, so then I go ahead and solve, factor like I did before, and I'll find that x can't be 3, x can't be negative 1. So putting these two restrictions together, x has to be a number bigger than or equal to -5. So a big solid dot there, or a bracket. It can't be the number -1 or 3. So here's -1. Here's 3. But it can be all the other numbers heading in that direction. So there's a space, there's a space, and then we got this final one coming out here to positive infinity. So it starts at -5, goes to -1, parenthesis, because we can't use -1, -1 to 3, and then 3 out to infinity. Okay. Let's try one more here. If I had changed the problem and put p of x equals the cube root of x plus 5 over x squared minus 2x minus 3. I look for my restrictions again, but notice this time you don't have a restriction in the numerator. You've got no even root. You've got an odd root here, so we don't worry about the numerator. The denominator, though, remember we said it can't be 0. And then solve it out just like we did before. X can't be 3, x can't be -1. So we're going to find, again, on your number line, those are the only two places that you have to avoid. So I have a space out here, a space in the middle, and a space on the right-hand side. So its domain goes from -infinity to -1 with a parenthesis, because it's not equals, between -1 and 3, and then 3 out to infinity. Okay, so the very last one, I promise, is what if I have a radical in the denominator? So I have x squared minus 4 over the square root of x plus 5. So I look at my restrictions again. There's nothing in the numerator. There's no radical, square root, nothing. So I don't have a restriction in the numerator, but I do have something going on in the denominator. I have underneath a radical that's even root. So normally I would do greater than or equal to 0, but because it's in the denominator, it can't be 0. So when I solve this out, x has to be bigger than or equal to -5, but x can't be -5. You're telling somebody on the number line, here's -5. It can't be -5 though. So you can't use the equals here. It goes off in this direction. So it's parenthesis -5 to infinity. And the reason it's parenthesis is because the denominator, if I plug in a -5, that's going to make a 0 in the denominator. And we can't have a 0 in the denominator.